Understanding the idea of controlling robots, drones, and prosthetics might be quite difficult because you're literally moving an object without using an inch of your body. You're using your mind. But how? The answer is brain computer interfaces. As you may guess from its name, BCIs create a direct communication pathway between your brain and a computer system. Well, in other words, your brain waves are translated into digital signals the computer can understand. Well, how does that happen? When you concentrate, think, or even relax, your neurons fire tiny electrical impulses. These electrical impulses can be detected by electrodes placed on your scalp, also a process we call EEG, or also when collected, these EEG signals are analyzed by algorithms that detect patterns across specific mental states, like focus, relaxation, or movement intent. Let's get deeper into BCIs. A typical BCI works on three main stages. Well, first, the system records brain activity, usually through EEG sensors that are placed on your scalp. Secondly, the raw electrical signals are processed and analyzed. Finally, the system translates those features into commands, creating a two-way path between the brain and a machine. Well, actually, in the last step, the two-way path that we talked about is where things get really interesting. The ongoing cycle of brain, computer, feedback, and brain is called the closed loop system. However, closing that loop system is actually one of the biggest challenges of neuroscience and AI today. Well, the brain is not static. It constantly changes through attention, emotion, fatigue, and distraction, making it difficult for computers to interpret brain data constantly. Building a system that can learn and adapt through those fluctuations, while also giving meaningful feedback, is called adaptive neurofeedback, or loop closure. The ultimate goal is to make BCIs intuitive, systems that can understand our brain signals just as naturally we understand vision or touch. Well, that's exactly what my project explores. I try to create a project that demonstrates how brainwaves are perceived by computers and systems. This system reacts to changes in alpha wave activity, which also demonstrates how a closed-loop BCI system might work in real time. The system visualizes the brain shifting space from focus, stress, and relaxation through dynamic color feedback. It's a small step towards understanding adaptive neurofeedback and how our minds could one day seamlessly control intelligent systems. Well, if you enjoyed my project and want to learn more about it, you can reach a Medium article and the GitHub link from the description down below. See you!